Okay, so here's our last video on factoring the difference of perfect squares. If you notice, I've included the instructions to factor completely in both 11 and 12 on the JMAP Factoring Difference of Perfect Squares 1A worksheet. And the reason I did that is because anytime you see those words factor completely on a Regents assessment, that means you're going to have to factor more than once. You're going to apply two strategies. And because this comes from the difference of perfect squares JMAP worksheet, you know that one of those strategies is going to be the difference of perfect squares. Now, they will not tell you what strategies to use. That will be up to you to figure out. But generally, when you see these two terms and you see factor completely, it's going to be the GCF along with the difference of perfect squares. So when we started factoring, we started out with the GCF. Now we're going to combine that with the difference of perfect squares. So we have two terms, they with a minus sign in between them, but we don't have perfect squares. 3 is not a perfect square and 27 is not a perfect square. But because I see the words factor completely, I know that I have to use two different methods. So there is a GCF here, which is between the 3 and 27 is a 3. And when I factor that out of a 3x squared, I have x squared left. The sign doesn't change, and a 3 comes out of 27 9 times. So this is why you need those words factor completely, because we did factor it. 3 times the quantity x squared minus 9 will give you 3x squared minus 27 back, but we didn't factor it completely. So we do have to go further with another strategy. Now this is where you look to the inside of the parentheses. That quantity is x squared minus 9. There's two terms, minus sign in the middle. I'm looking for the difference of perfect squares. X squared is a perfect square, so is 9. So I could take it one step further, and there are my two conjugates. X times x is going to give me that x squared back. 3 times negative 3 is going to give me the negative 9. And then when I take that quantity and multiply it by 3, I get the original back. So that's what you want to do for your check. Okay, one more. Factor completely. Again, I know that the difference of perfect squares is involved because it comes from that worksheet, but you necessarily wouldn't know that on an assessment. So when you see those words factor completely, it almost always is GCF involved. Maybe not every single time, but 95% of the time a GCF is involved. So you look at these terms, 2 and 50, they do have a common 2. There's no variable terms. Sometimes you could have common variable terms, but in this case there isn't. So when I take a 2 out of a 2x squared, I have x squared left, and when I take a 2 out of a 50, I have 25. So if I multiplied the 2 times x squared minus 25, I should get 2x squared minus 50 back, and you will. Factor completely means I'm going to have a second method, and because I have the two terms with a minus sign in between, both terms being perfect squares, I can take the square root of x squared. It'll give me x. I take the square root of 25. I get 5. And I know they have to be opposite signs, or what we call conjugates of each other. So we have 2 times the quantity x plus 5 times x minus 5. That is factored completely.